When calculating the electrical load for a suite within a multifamily dwelling that has common laundry facilities, the question arises whether to include the 1500-volt amps designated for a laundry circuit in the suite's load calculation, even when the suite itself lacks any laundry equipment. The answer is no. It's not necessary to include this 1500-volt amps load in the suite's calculation. This approach stems from the understanding that the laundry needs are met by the common laundry area, preventing a redundant load calculation for individual suites. This aligns with standard electrical engineering practices and considerations for diversity factors in multifamily buildings. Including the 1500-volt amps for each suite would result in an overestimation of the total building load, potentially leading to oversized electrical service equipment. This is because the probability of every suite using a laundry circuit simultaneously is extremely low, especially when a common laundry facility is available. The National Electrical Code, or NEC, provides guidelines for calculating electrical loads in residential buildings. These guidelines often allow for demand factors to be applied, acknowledging that not all loads will be operating at their maximum capacity at the same time. When dealing with common laundry facilities, the NEC permits the load calculation to reflect the presence of this shared resource, avoiding the unnecessary addition of a dedicated laundry circuit load for each individual suite. The proper application of demand factors is crucial in electrical design. Demand factors are multipliers used to reduce the calculated load to a more realistic value, taking into account the diversity of usage. In multifamily buildings, different types of loads contribute to the overall demand, including lighting, receptacles, appliances, and heating or cooling systems. When a common laundry facility is present, its load is typically calculated separately and then factored into the overall building load. It's important to consult the specific sections of the NEC relevant to multifamily dwellings and load calculations to ensure compliance. These sections provide detailed instructions on how to determine the demand factors applicable to different types of loads and occupancies. In the context of a suite lacking laundry equipment, the absence of a laundry area eliminates the need to account for the associated 1500-volt amps load. Instead, the suite's load calculation should focus on the actual loads present within the suite, such as lighting, general-purpose receptacles, and any dedicated appliance circuits. Consider a scenario where a multifamily building contains 20 suites, each without individual laundry facilities but served by a common laundry room. If the 1500-volt amps laundry circuit load were incorrectly included in each suite's calculation, the total additional load would be 30,000 volt amps. This inflated load could lead to the selection of a larger service entrance, panel boards, and conductors than are actually necessary, resulting in increased costs and wasted resources. Accurate load calculations are essential for ensuring the safe and efficient operation of electrical systems. Overestimating the load can lead to unnecessary expenses, while underestimating the load can result in overloaded circuits and potential fire hazards. Therefore, it's crucial to carefully consider the actual loads present in each suite and to apply the appropriate demand factors based on the NEC guidelines. In addition to the NEC, local electrical codes and regulations may also provide specific requirements for load calculations in multifamily buildings. It's important to be aware of these local requirements and to ensure that the electrical design complies with all applicable codes. The electrical designer should work closely with the building owner and the local electrical inspector to clarify any questions or concerns regarding load calculations and code compliance. When determining the load for a multifamily suite, it's also important to consider any future expansion or changes that may occur. For example, if there's a possibility that the suite may be renovated to include laundry equipment in the future, it may be prudent to include a provision for a laundry circuit in the electrical design. However, this decision should be based on a careful assessment of the likelihood of such a change and its potential impact on the overall electrical system. The electrical design should also take into account the energy efficiency of the building. Energy-efficient appliances, lighting, and HVAC systems can significantly reduce the overall electrical load and operating costs. By incorporating energy-efficient technologies into the design, it's possible to reduce the size of the electrical service equipment and the amount of energy consumed by the building. The use of energy-efficient measures can also contribute to a more sustainable and environmentally friendly building design. The selection of appropriate conductors and overcurrent protection devices is also crucial for ensuring the safety and reliability of the electrical system. Conductors must be sized to carry the calculated load without overheating, and overcurrent protection devices must be selected to protect the conductors from overload and short-circuit conditions. The NEC provides detailed tables and guidelines for selecting the appropriate conductors and overcurrent protection devices based on the calculated load and the type of wiring method used. Proper grounding and bonding are also essential for ensuring the safety of the electrical system. Grounding provides a low-impedance path for fault currents to return to the source, allowing overcurrent protection devices to quickly trip and to energize the circuit. Bonding ensures that all metal parts of the electrical system are electrically connected, minimizing the risk of electric shock. The NEC provides detailed requirements for grounding and bonding, which must be strictly followed to ensure the safety of occupants and the integrity of the electrical system. In summary, when calculating the electrical load for a suite in a multifamily building with common laundry facilities, it's not necessary to include the 1500 volt amps for a laundry circuit if the suite doesn't have laundry equipment. This approach aligns with standard electrical codes and practices, avoids overestimation of the building's total load, and promotes efficient electrical design. It's crucial to consult the NEC and local electrical codes to ensure compliance and to consider future expansion possibilities and energy efficiency measures. Accurate load calculations, proper conductor sizing, appropriate overcurrent protection, and effective grounding and bonding are all essential for ensuring the safe and reliable operation of the electrical system. Remember to always consult with a qualified electrical engineer or electrician for any electrical design or installation work. Electrical work can be dangerous and should only be performed by trained professionals. Additionally, understanding the specific occupancy requirements outlined in the NEC is vital. For example, the NEC might have different requirements for dwelling units in multifamily buildings versus commercial spaces within the same structure. Therefore, accurately classifying each area based on its intended use is a fundamental step in the load calculation process. Consider, too, the impact of any large appliances that might be present in some, but not all, suites. While a standard suite might only have typical loads like lighting and small appliances, another suite could have a large electric range or supplemental heating system. These larger appliances require dedicated circuits and significantly impact the overall load calculation for that specific suite. The NEC provides guidelines on how to calculate these appliance loads, often requiring the nameplate rating of the appliance to be used. Furthermore, don't forget the importance of considering voltage drop. Voltage drop occurs when the voltage at the end of a long conductor run is significantly lower than the voltage at the source. Excessive voltage drop can cause appliances to malfunction and can even damage electrical equipment. The NEC provides recommendations for maximum allowable voltage drop, and conductors must be sized appropriately to minimize voltage drop. The length of the conductor run, the current flowing through the conductor, and the conductor's resistance all contribute to voltage drop. When planning for future electrical needs, it is generally better to overestimate the load if you are unsure of what the suite may become in the future. An overestimation is better to ensure there is no overloading that can cause circuit breakers to trip. When completing a load calculation for a panel, it's useful to break down the amperage by circuit so that you can accurately balance the load. A three-phase system needs to be carefully calculated to ensure that each phase has roughly the same load. It's also important to understand the difference between continuous and non-continuous loads. A continuous load is a load that is expected to operate for 3 hours or more at a time, while a non-continuous load is a load that operates for less than 3 hours at a time. The NEC requires that conductors and overcurrent protection devices be sized to handle 125% of the continuous load, in addition to the non-continuous load. This requirement helps to prevent overheating of conductors and ensures the reliability of the electrical system. Also consider all local amendments to the NEC that are applicable to the area you are working in. The local amendments can be more restrictive than the NEC and may require changes to the project. Always verify with the authority having jurisdiction or AHA to be sure you follow local requirements. It is also important to factor in the ambient temperature when selecting conductors. Conductors are rated for a specific ampacity at a given temperature, typically 30 degrees Celsius or 86 degrees Fahrenheit. If the ambient temperature is higher than the rated temperature, the conductor's ampacity must be derated to prevent overheating. The NEC provides tables that show the derating factors for different conductor types and ambient temperatures. Another aspect to think about is the effect of harmonics on the electrical system. Harmonics are non-sinusoidal waveforms that can be generated by electronic devices such as computers, LED lighting, and variable frequency drives. Harmonics can cause a variety of problems, including overheating of transformers and conductors, increased voltage distortion, and malfunctioning of sensitive electronic equipment. If harmonics are a concern, it may be necessary to install harmonic filters to mitigate their effects. Be sure to conduct regular maintenance on electrical systems to ensure safety and proper functionality. This may include replacing old circuit breakers, tightening connections, and visually inspecting wiring.